For the first half of 2026, high-tier machine intelligence operated as a closed system. Accessing frontier-level capabilities meant paying a premium to Anthropic or OpenAI, leaving the industry dependent on a handful of proprietary APIs. This changed with the release of Kimi K3. At 2.8 trillion parameters, Moonshot AI's latest model arrived without a traditional launch campaign and immediately began matching the performance of the world's most expensive systems. This chart displays early results from the Towards AI writing benchmark, which uses an ELO system to rank models based on blind human preference. Claude Fable 5 sits at 2760, while Kimi K3 takes the top spot at 2840. The lead extends into technical tasks. On Bridgebench, K3 won 7 of 8 arenas against Fable 5, including a 9-0 victory in code refactoring. We are tracking this shift toward open-weight dominance as it happens. We are very close to reaching our 1,000 subscriber milestone. Hit the button to help us get there before our next deep dive. For 2 years, the assumption was that the sheer financial cost of training a frontier model created an insurmountable moat. The performance of K3 proves that open-weight systems can now reach the same capability ceiling as the most guarded proprietary models. While the intelligence benchmarks are a factor, the real disruption is economic. Kimi K3 pairs a 1 million token context window with an automatic caching system that changes how long horizon work is priced. In this comparison, Claude Fable 5 costs $10 per million input tokens and $50 for output. Kimi K3's baseline is significantly lower, starting at $3 for input and $15 for output. With a cache hit, querying a stable codebase drops the input cost to 30 cents per million tokens, a 90% discount. This makes million token memory a standard feature rather than an expensive exception. It allows for the repeated analysis of massive datasets at a price point that was recently impossible. Running a model with 2.8 trillion parameters requires a massive computational footprint. Traditionally, a model of this size would exceed the hardware capacity of all but the largest enterprise data centers. Moonshot manages this scale through an architecture called Stable Latent MOE, or a mixture of expert system. Instead of using the entire network, the model divides into 896 expert subnetworks. For any specific task, it activates just 16 experts. This selective activation pairs with Kimi Delta attention, significantly improving processing speed across very long sequences of text and code. By only engaging a fraction of its total parameters at once, Moonshot can scale the model's knowledge to 3 trillion parameters without requiring a linear increase in power and hardware. This architecture is built for autonomous work. An agent can load an entire software repository into its million-token memory and iterate on it continuously without the per-token costs becoming a barrier. During development, K3 was used to optimize its own compute kernels. In a single 15-hour session, it profiled and rewrote code for high-performance GPUs, cutting execution time from 283 milliseconds down to 114. It can also integrate visual feedback into the development process. By analyzing screenshots of its own output, K3 can procedurally build 3D game worlds and interactive web components entirely from scratch. These cases show that K3 is not just answering questions, it is executing complex, multi-hour engineering tasks with minimal human intervention. The most significant change arrives on July 27, 2026, when Moonshot is scheduled to release the full model weights for K3 to the public. This release enables data residency for high-security industries. Healthcare and finance teams that cannot legally send proprietary data to an external API can instead run K3 on their own isolated servers. Self-hosting a model of this magnitude is a significant technical undertaking. Running a 2.8 trillion parameter system requires specialized, enterprise-grade hardware that is currently beyond the reach of local consumer setups. But for those with the infrastructure, frontier-level intelligence is no longer a service you have to license from a third party. It is a tool you can own. The capabilities of K3 push the user workflow beyond simple back-and-forth messaging. The technical documentation for K3 makes this transition explicit. As the guide states, the time of manual prompting is finishing. We are now building autonomous pipelines, where the model handles complex logic without supervision. K3 is designed to function as an independent engine. You deploy it to solve a high-level engineering problem, and it works through the logical dependencies until the task is complete. The barrier between proprietary power and open availability has been removed. The frontier is open, and it is time to stop chatting and start building.